Okay, so we have seen the first case of distance time graph, that is when a body is at rest. Now let's consider the second case, when the case number 2, that is case B, when a body is in uniform motion. Okay, the second case that we will consider is when the body is in uniform motion. Now what exactly is uniform motion? When a body travels equal distances in equal intervals of time, the motion is said to be uniform motion. Okay, this is the basic definition of uniform motion. So we will consider that definition, and let us say we draw something like this. Let's say I consider this point as a reference point. Okay, let's say this is my reference point. From this point I am observing the motion. Okay, from this point let's say I am observing the motion. Let us say I am standing exactly on the bus stop, or let's say I am standing near the bus. I am very close to bus, that is the bus and the observer both are standing, let us say, at this reference point. So what will happen when the bus starts moving? Let us say when I started observing the bus, I was standing with the bus at this point. So I will say at t is equals to 0, this is the position of bus as well as the observer. Both the observer and the bus are standing at the same point, and at t is equals to 0 means when the observer started observing the bus, it is standing at this point. Okay, so what is the initial distance between the bus and the observer? It's 0, it's totally 0 because they are standing very close to each other. Okay, so let's say the bus started moving, let's say bus started moving and bus is traveling in this manner. Let's say the bus travels 10 meters in 1 second. Okay, then again the bus travels 10 meter in another 1 second. Then let's say again the bus travels 10 meters in another 1 second, and again 10 meters in another 1 second, and so on. Okay, and so on. So it means what I am considering is bus is traveling 10 meters of distance in every 1 second. So when I saw the bus for the first time, the bus is at this point, that is t is equals to 0 when I started observing the bus. After 1 second, at t is equals to 1, the bus is at, let us say, point A. Then after 1 more second, that is at t is equals to 2, the bus is at point B. Then after 1 more second, at t is equals to 3, the bus is at point C, and so on. The bus started moving. So t is equals to 4, the bus is at point D. So what I can say, after every 1 second, the bus is moving 10 meters away. Okay, it is moving 10 meters away from the reference point. Okay, so if I make a table of this data, if I make a table of this particular thing, I will write time and then I will write distance. Okay, I will write time and then I will write distance. So at 0 seconds, the distance travelled by the bus is 0 because bus and the observer both are standing at the same position. Then after 1 second, the bus travelled 10 meters. Then in the next 1 second, that is at t is equals to 2, the bus is 10 plus 10, that is 20 meters away. Okay, so you can see the bus is 10 meters at the first point, and then again in 1 second the bus travelled 10 meters. So it is 20 meters away from the starting point. Then at 3 seconds, the bus is again travelled further 10 meters. So it has travelled 30 meters, and then at 4 seconds or after 4 seconds the bus had travelled 40 meters. So after 5 seconds it would have travelled 50 meters, and so on. This is a kind of table that I can make. Okay, so this is the data given to me. Now let's try to make a graph. Let's try to plot a distance time graph using this given data. Distance time graph is the most important graph. Please understand it very carefully. This is the most important graph in this topic. Okay, this is the most important graph. See, this is the time. in bracket we will write the unit, that is seconds, on the horizontal axis, and this is the distance, that is in meters. We will measure it on this axis, that is vertical axis. Now let's plot the time. You can see the time is in 0, 1, 2, 3, 4 and 5 and so on. So this is the 0 seconds, this is 1 second, this is let's say 2 seconds, this is let us say 3 seconds, this is the 4 seconds, and this is the 5 seconds, this is 6 and so on. It will continue. Okay. And what is the distance? Distance is 0 meters, then 10 meters, then 20 meters, then 30 meters, then 40, then 50, then 60 and so on. This will continue. Okay. So let's plot this data on this graph. At t is equals to 0 second, the distance travelled by the object is 0 meters. So the position of the object at t is equals to 0 second is this point. Okay. Remember the first case. We saw that the bus was already standing 10 meters away when I started observing the bus. But in this case, what we are considering, the bus and the observer both are standing at the same point. Okay. So it means the distance between them is 0 meters. So when I first started observing the bus was just close to me and the distance between me and the bus is almost 0. That's why we consider that at t is equals to 0, at time is equals to 0 seconds, the distance is 0, or the position of the bus is 0 meters. Okay. Now after 1 second the bus has travelled 10 meters. Okay. So at the 1 second I will draw a vertical line like this, and at the 10 meters I will draw a horizontal line like this, and this would give you the point of intersection, that is, this is the point A. I will say the point A which we have drawn in the diagram is represented like this on the graph, because this point represents at 1 second the bus has travelled 10 meters, that is at exactly 1 second or after 1 second the position of the bus is 10 meters from the reference point. Okay. So this point A represents after 1 second position of bus is 10 meter away from reference point. Okay. From the reference point the bus is exactly 10 meters away. And what does this 0 represent? It represents that after 0 second or at 0 seconds the bus is at 0 meters away from the reference point. Okay. Let's see the second case. When after 2 seconds, okay, after 2 seconds the bus has travelled 20 meters. So the bus would be at point B after 2 seconds. So how can I mark the point B on this graph? At 2 seconds means at this point. So I draw a vertical line of this point, 2 seconds, and 20 meters means this horizontal line like this. So this is the point B, because this will going to represent the position of the bus at 2 seconds. Okay. So just exactly at 2 seconds or after 2 seconds, the point at which the 2 second is completed and 3rd second is going to start, that point is known as t is equals to 2 seconds. So at that point the bus is at 20 meters away from the reference point. Similarly, if I plot the 30 meters, it will be something like this. This would be the point C. Okay. Similarly, if I plot 40 meters, that is at 4 seconds, the bus would be at this point, that is point D. And similarly, if I plot 50 meters, this is the point E, which represents, or 50 meters means, let us say we have marked this point on the graph. On this diagram I have shown only point D, but you can continue this like this. Okay. So what we can see, these are the positions of the object at different point of time, that is at 0 second, 1 second, 2, 3, 4, 5, 6 and so on, and these are the distance of position, okay, from the reference point, 10 meters away, 20 meters, 30, 40 and so on. So if I ask you how much distance the bus has travelled in 1 second, the distance travelled by the bus in 1 second, you can see in, let's say at t is equals to 2 seconds, the bus is 20 meters away, and at t is equals to 1, it is 10 meters away. So during this 1 second, the bus has travelled 10 meters. Okay, during this 1 second, the bus has travelled 10 meters. So at equal intervals of time, the bus is travelling equal distances. Hence, it is a uniform motion. We have considered it. So we have marked this on graph, and how we can plot the graph of this particular case. If I want to plot the graph, I will join all these lines, and this line would be a straight line. Okay, this would be exactly a straight line. Since I am drawing in the board, so it might not look like a straight line, but assume it as a straight line. So I will say it is a straight line which describes the motion of object. Okay, this straight line describes the motion of an object which is performing uniform motion. So for uniform motion, I will going to have a straight line like this. Okay, this is the straight line that we can have for a uniform motion. Now, as we have seen in the previous case, the line was exactly parallel to horizontal, which gives us that the object is at rest. But here we can see that line is not horizontal, it has some angle. It is making some angle with the x-axis. Okay, this is the horizontal axis. Since it is making some angle with the x-axis or horizontal axis, I can say the object is in uniform motion. Okay, I can simply say the object is in uniform motion because it is making some angle with the x-axis. Now we call this angle as theta. Let us say we call this angle as theta. This is angle theta. Theta is used to denote some unknown angle. So we don't know what exactly this angle is, but we can denote it by theta. That is theta degrees. You have studied this in your previous class. Now here we will define a new term. And that term is slope. Okay, here we will define a new term, that is slope. The slope of this straight line. The slope of straight line is equal to tan theta. Okay, the slope of this line is equal to tan theta. Now you may wonder what is tan theta. So tan theta is a trigonometric function. You will study this in your topic trigonometry. When you study about trigonometry, you will understand the concept of tan theta. At this point of time, just remember this line, that slope is a term which is used to define the which is basically tan theta of this line. Okay, now we will understand why exactly we are defining the slope. First of all, try to recall what definition we have studied about velocity. We know that velocity is basically displacement upon time. Okay, velocity is basically displacement upon time. So what we can see, if I divide the displacement by time, I will get the velocity. Okay, if I divide displacement and time, I will get the velocity. So it means if I divide this distance or displacement, you can say, because we are considering a straight line motion. The motion of the object is in a straight line, so distance and displacement would be one and the same thing. Okay, so if I divide this distance by time, I would get the velocity. So the significance of this kind of graph, the significance of distance time graph is that using this graph we can calculate the velocity of the object. Okay, so let's write it here. Significance of distance time graph is that we can calculate the velocity of the object. Using this graph we can calculate the velocity of the object. Now how can we calculate the velocity? Observe this. For example, I consider a point here. Let us say it is let's assume this is M. Let's say this point is M. Okay, and if I talk about this point M, what does this represent? This point M represents the position of an object with respect to time. At some given time, the position of the object is represented by this point M. So let us say I draw a line like this through this point M. Let's say this is a time and this is the distance. As we studied, distance is the displacement is generally represented by S. So let us say at this point M, in t1 time the object has travelled s1 distance. In t1 time object has travelled s1 distance. Okay, why it is so? Because you can see, for example, point C. What does this point C represent? It represents at 3 seconds the object is 30 meters away. At B represents at 2 seconds is the object is 20 meters away. So let us say at point M at t1 seconds the object is s1 meters away from the reference point. Okay. Similarly, I will consider one more point, let us say point N, and point N will represent, let us say at t2 seconds the object is s2 meters away from the reference point. At t2 seconds the object is s2 meters away from the reference point. M represents at t1 seconds the object is s1 meters away from the reference point. Okay. So if I ask you how much time has been elapsed between these two t1 and t2, the time between t1 and t2, the time elapsed between this t1 and t2 is t2 minus t1. And what is the distance that the object has travelled during this duration? You can see, for example, if I talk about point B and C, the distance that object has travelled from point B and C can be calculated using these two values, using the difference of these two. At point C it is 30 meters away from the reference point, at point B it is 20 meters away from the reference point. So during B to C it has travelled 30 minus 20, that is 10 meters of distance. Okay. So what I will write, I will say that M represents the object is the point M represents that object is s1 meters away from reference point. Okay. What does this point M represents? It represents that object is s1 meters away from the reference point at t is equals to t1 second. So exactly at t1 second if I talk about, so at t1 second the object is s1 meters away from the reference point. Similarly, what does this n represents? It represents the object is s2 meters away from the reference point at t is equals to t2 seconds. So at t is equals to t2 second, object is s2 meters away from the reference point. Okay. So if I ask you the time between point M and N, so time between point M and N would be t2 minus t1, okay, t2 minus t1, and the distance traveled between m and n is s2 minus s1, okay. So what we can see, velocity is what? It is displacement upon time. So distance or displacement traveled between this point m and n is this one, s2 minus s1, this is the distance traveled, and how much time it has taken, t2 minus t1, this is the time taken. So the velocity from point m, or velocity between m and n will be equals to, what is the velocity? It is displacement upon time. What is displacement? s2 minus s1. What is time? It is t2 minus t1. So I will say velocity v will be equals to s2 minus s1 upon t2 minus t1. I will say velocity is s2 minus s1 upon t2 minus t1. So observe this. If I draw a triangle like this, if I draw a triangle using this point m and point n, now what kind of triangle? I draw a horizontal line from this point n, from point m, and a vertical line from point n. So this will be going to intersect at this point. So this will be a triangle. Now in this triangle, what is s2 minus s1? This is the s2 minus s1. This is equal to what? This is equal to this line. Okay, this is equal to this line, that is perpendicular. See, this is a right triangle. In this right triangle, this is the s2 minus s1, and what is t2 minus t1? This is t2 minus t1. So this is the t2 minus t1. So I will say, what does this s2 minus s1 upon t2 minus t1 is representing? I will simply say that it is representing tan theta. Okay, because tan theta is basically something that is perpendicular of a right triangle upon base of the right triangle. Just understand this concept here only, only this much, but you will understand this in trigonometry. Okay, so we will not indulge into that topic. We will simply learn this, that velocity is what? It is s2 minus s1 that upon t2 minus t1, that is equal to tan theta. Okay, tan theta, which is also known as the slope of the line. Now imagine this is the angle. Now why it is significant? Why I am writing it as tan theta? It's because this tan theta or slope, where we can write, let's say I write here, the slope help us to judge the velocity of the object. See, what will happen? If this angle is increasing, then automatically this s2 minus s1 will going to increase and the velocity will increase. Okay, if this angle is small, if this angle is very small angle, then I would say the theta, this angle will decrease. If this angle decreases, this tan theta will also decrease. Okay, this is the relation between theta and tan theta. You will learn in trigonometry this relation. We will simply learn right now. If theta decreases, this tan theta will going to decrease, and if this tan theta decreases, the velocity will automatically going to decrease. So in simple way, I would say that theta is related to tan theta and tan theta is related to velocity. So in simple way, I will say more theta means more velocity, less theta means less velocity. So I will simply say in one thing that theta or velocity is proportional to theta. Velocity is directly proportional to theta. If this angle is increasing, I can simply say, just by looking at the graph, I will say that velocity is increasing. If this angle is decreasing, I will say just by looking at the graph, I would say that velocity is decreasing. Okay, we will understand that concept in or we will solve some questions based on this concept. For time being, just remember these two things, that velocity is dependent on this angle. More angle, more velocity, less angle, less velocity. This is the basic concept. Okay, just remember this concept, and you can note this, and we will continue with the third kind of displacement distance time graph, that is non-uniform motion. Okay, you can note this.